Now we are going to discuss about exercise 9.5. Here the improper integral. We are going to see the improper integral. So the integration of the type integral minus infinity to plus infinity f of x dx, plus infinity to a f of x dx, and a to infinity f of x dx is known as improper integral. That is, if you are having any one of the upper limit or lower limit is infinity or minus infinity, or both upper limit and lower limit is known as infinity and minus infinity, it is known to be improper integral. So we have some results in this exercise. This is very easy exercise. Only we have to see the three formulas, that's all. Using this only we are going to do. So we have one example sum and we have two exercise sums. So all the three problems are very easy. Using these three formulas only we are doing this. So integral 0 to infinity dx by a square plus x square is equal to pi by 2a. Integral a to infinity dx by a square plus x square is equal to pi by 4a. Just look at this. 0 to infinity means pi by 2a. A to infinity means pi by 4a. Suppose this integration of the type minus infinity to plus infinity dx by a square plus x square means this is pi by a. So that's all. These are the three formulas. Using this only we are going to evaluate. So now exercise 9.5, the first problem, evaluate 0 to pi by 2 dx by 1 plus 5 cos square x. So here just look at this integration. We cannot do direct formula. We cannot use the formula method. Any formula we cannot use, and any integration methods we cannot use. So we should know that this is a improper integral. We want to convert as improper integral. With that only we want to evaluate this. So I want to divide these term by cos square x. Both numerator and denominator I am going to divide by cos square x. So dx by cos square x by 1 plus 5 cos square x by cos square x. So dx by cos square x means secant square x dx. So if I divide these number, this will be 1 by cos square plus cos square cancel plus 5. So integral 0 to pi by 2 secant square x dx by secant square x plus 5. So I can write this secant square x is nothing but 1 plus tan square x plus 5. So this is secant square x by tan square x plus 1 plus 5 is 6 into dx. So I am going to take t is equal to tan x. Then dt will become secant square x. So I want to change this integration, all the x terms as t. Then this limits also must be changed. This limits also must be changed. So whenever x is equal to 0, t is equal to tan 0. That is t is equal to 0. Whenever x is equal to pi by 2, t is equal to tan pi by 2. That is t is equal to infinity. So this integration 0 to pi by 2 secant square x dx by tan square x plus 6 will become 0 to infinity dt by t square plus 6. So 0 to infinity dt by t square plus this 6 can be written as root 6 whole square, because I want to write this as in the form of x square plus a square format. So that only I am changing this 6 as root 6. So we know that 0 to infinity dx by x square plus a square is equal to pi by 2a. So here a is equal to root 6. So directly I can substitute 0 to infinity dt by t square plus root 6 whole square is equal to pi by 2 root 6.